Okay, I'm going to skip slide number 1. So this is the Desmos for lesson 26. I'm going to skip slide number 1 because that's the check-in, and then the first few slides are a warm-up. So this is an example of a right triangle. So a right triangle always has one right angle, and then they have two legs. Those are the sides that help create the right angle. And then it has a hypotenuse, and that's always the longest side, and it's the side that's across from the right angle. So sometimes it's hard to tell what the longest side is, so it's important to know that the hypotenuse is always like across or opposite of the right angle. And then the legs, like I said, those help create the right angle. Those are the two shorter sides. All right, so for the first warm up, we're just going to label each side. So I'm going to label the hypotenuse first. So I look for the side that's across from the right angle. So that's this one right here. And then typically we don't have to like necessarily tell the difference between like the shorter leg and the longer leg, but just for the sake of the warm up we will. So these are the two legs right here. We can see the shorter one is that one that's kind of on top, and then the longer one is the one that's on the left side. And then again, the legs help create the right angle. And then the next warm up, so I'm going to start with hypotenuse again. So I look for my right angle. I look for the side that's across or opposite the right angle, and that's this one right here. And then the shorter of the two legs is this one. The longer of the two legs is this one. And then this is Unit 6, Lesson 26, with just Pythagorean theorem and similarity. So the goal is to be able to use this formula called the Pythagorean theorem to find missing sides of right triangles. Okay, so the Pythagorean theorem, the formula for it is a squared plus b squared equals c squared. So I'm going to jump down to the second paragraph. So we use the letters A and B for the lengths of the legs, and then we use the letter C for the hypotenuse. So the C in the formula specifically has to go with the hypotenuse, again, the longest side and the side that's across from the right angle. And then A and B have to be the legs. It's not like A has to be the shorter leg and B has to be the longer leg. A and B are like interchangeable, so they just need to be the two legs. And if you switch them from what I set up, that's totally okay. You'll still get to the correct answer. All right, so use the Pythagorean theorem to find the value of C. So in this problem, you can see like C is the hypotenuse because it's across from the right angle. So that means that we know the two legs, the 5 and the 12, and want to solve for the hypotenuse. So I'm going to start with just putting the formula in here so I can type directly into it. So a squared plus b squared equals c squared. A and b are the two legs. It doesn't matter which is which though. So I'm going to say 5 is A and then 12 is B. You could say 12 is A and 5 is B. It really doesn't matter. All that matters is that the hypotenuse is C. So if I say A is 5, I'm going to put 5 in for A. So it'll be 5 squared. Oops, I didn't click the equation one. So it'll be 5 squared. We're going to keep the squared up there, that little 2. It's an exponent. And then plus we said B was 12, so 12 squared equals C squared. We're eventually going to want to solve for C. So in order to do that, I want to simplify the left side of the equal sign. So think like order of operations. So I have exponents there and then addition. I would need to simplify the exponents first before addition, so I need to square each. So 5 with an exponent of 2 means 2 5s multiplied together, so 5 times 5 is 25. And then the 12 with the little like raised 2 next to it means 12 times 12, or 2 12s multiplied together, so that would be 144. And then equals c squared. And then now that I have simplified the exponents, I can go ahead and simplify the addition part. So it'd be 25 plus 144, that's 169, equals c squared. And then I don't really care what c squared is. I need to know what just c is. So I want to get rid of that squared part. So I'm going to use the like inverse of squaring something, which would be square rooting something. So it's going to cancel out the little exponent. And then whatever I do to one side, the equal side, I need to do to the other side. So I'd have to square root the 169 as well. So the square root of 169 is 13. So square root of 169 is 13. And then square root of c squared, that's just going to cancel out the exponent, and it's going to leave me with just c. So I end up with c equals 13, and the question is asking what is the value of c, 13. Get that entered in, and then you're good. If you aren't sure what like a square root is in general, like of any number, the Google calculator, I'm just going to use that one because everybody has access to that. The square root button is right here. So you do square root and then 169 equals, and then it gives you 13. So square root of 169 would be 13. All right, so number 8, so same thing, we're finding a missing side of Pythagorean, or using Pythagorean theorem. So I just want to compare 7 to 8 really quick. So notice with 7, we were missing the hypotenuse, C. So C was like our unknown variable in Pythagorean theorem. In slide 8, or on slide 8, we know the hypotenuse. It's 15 because that's the side that's across from the right angle. So we're going to be solving for a different letter this time, either A or B. It doesn't matter. Okay, so I'm going to copy the formula down again. So A squared plus B squared equals C squared. And then I'm going to start labeling like A, B, and C. So the hypotenuse has to be C. So I'm going to put a C above that 15 because that's the hypotenuse. And then for the 12, that can be A or B. It doesn't matter. So I'll say, I'm going to call it B, and then I'm going to say this other side over here is A. And that's just going to be our variable that we're solving for. So we don't know what this side is, so I'm just going to leave it as A squared. That's what we use variables for, is to like put unknown values. So A squared plus, and then we said B is going to be 12. So I'm going to put 12 in for B, so it'd be 12 squared, equals C squared. So we said C was 15, so it'd be 15 squared. And then this problem looks a little bit different because this time, like, it's the A that's unknown over here versus the C that's was unknown over here on slide 7. But the first step is still the same. It's to square any number that you can. So like the A squared, I can't square that because it's just a variable. I don't know what A is yet. But the 12 squared, I can square that. So 12 squared means two 12s multiplied together, so it'd be 144 equals, and then 15 squared, that means 15 times 15, so it's 225. And then on the previous slide, the next step we did is we added these two numbers together, but we can't actually do that because we don't know what A is. So now we want to just think of it as like solving an equation where we want to try to isolate A. And so if we want to isolate A to like solve for it, I would want to cancel out that 144 that's being added to it. So I would subtract 144 right there. And then whatever I do to one side of the equal sign, I have to do to the other. So I'd subtract it from the other side of the equal sign underneath the 225. So these would cancel out because it's 144 minus 144. And then the A squared, I would bring that down. The 144 is cancel each other out. And then 225 minus 144, it should leave me with 81. Let me double check that. Yeah, so 225 minus 144 is 81. And then now we have something that looks similar to slide 7. So we have like a number square, or a variable squared equals 81. So I want to solve just for A in this case. I don't really care what A squared is. I want to know what just A is. So I want to cancel out that exponent. So I'm going to square root both sides to get rid of that squared exponent above the A. So when I do that, it's going to cancel out the power, and it's going to leave me with just A equals, and then the square root of 81 is 9. And square roots are just asking like what number times itself equals the number inside the radical. That's what the like square root thing is called, as a radical. Or like what number squared equals that number inside the radical. So like 9 squared is 81. So the square root of 9, or square root of 81 is 9, and vice versa. But you can always use a calculator if you need to. So square root of 81 is 9. So the missing side here is 9. All right, and then slide 9, this is like the final practice problem. So it says a TV is sized based off the length of its diagonal. And that's true, like all TVs, that's how their sizes are advertised. So the diagonal AC. So a TV is sized based on the length of its diagonal. The following TV has a length of 17.1 inches, so that's from A to B. and a height of 10.4 inches, so that's from B to C. What is the TV size, length, the diagonal, round to the nearest whole number? So if you were to go to a store, and you wanted to buy like this size TV, whatever we find for our final answer, that's going to be like the size that it would be advertised as. So it's not going to be advertised as like a 17.1 inch TV or a 10.4 inch TV. It's going to be advertised as like the length of this diagonal here. And you can see like we just kind of took this rectangle shape that was the TV and we created a right triangle out of it, because this is a right angle down here. And then if this is our right angle down here, that means that this has to be our hypotenuse. So if that's our hypotenuse, I'm going to go ahead and label that with like a C, just so I don't forget. And again, we know that that is the hypotenuse because this is it's a TV, so it's a rectangle shape. So all four corners would be 90 degrees or right angles. So that means this would be 90 degrees, and the side that's opposite of it, that C side, the one that's labeled in orange, that would be the hypotenuse. And that means the other two sides that we know are going to be our legs. So the 17.1 and the 10.4, those are our legs. And so those can be A or B, A and or B. It doesn't matter which one, you can switch them or keep them the same as mine. I'm going to say A is 17.1, B is 10.4. And again, these could be switched and it won't change the outcome, the final outcome. So if we want to solve for C, so we have a right triangle. We know two of the three sides of the right triangle. So as long as you know 2 out of 3, you can use Pythagorean theorem. So A squared plus B squared equals C squared. So I said A was going to be 17.1, so it'll be 17.1 squared. Plus B was 10.4, so it'll be 10.4 squared. And then equals C, so C, or equals C squared, excuse me. And that's what we're trying to solve for, so we just leave C as C. So 17.1 squared means 17.1 times itself, so 17.1 times 17.1. If you grab a calculator, it's 292.41. And then plus 10.4 squared is 108.16. And then equals C squared. And then now this problem is really similar to the first one we did, like back on slide 7, where we know these two numbers here, so I can go ahead and add them together. So we'll do 292.41 plus 108.16. And so when we add those together, it ends up being 400.57 equals C squared. And then we don't really care for what C squared is. We want to know what just C is. So I have to get rid of that exponent. So I'm going to square root both sides. So square rooting the right side is just going to cancel out the exponent and leave me with just C. And then notice the question says round to the nearest whole number. So if I take the square root of 400, it's going to give me like 20 point something. But I don't need to include the decimal because it says round to the nearest whole number, and that's just everything before the decimal mark. So it'll be approximately 20 inches, equals just C, because like I said, the little exponent here got canceled out. I'm going to switch over to the calculator part really quick just to kind of do a quick review of rounding. So we were taking the square root of 400.57. And so it ended up being like 20.014 and so on, dot, dot, dot. It says round to the nearest whole number, so that's everything before the decimal place. You still want to look at the first, like the next number after what you're rounding to. So in this case, it would be the first number after the decimal. If that number were 5 or more, it would round the 20 up to a 21. But it's not 5 or more, it's 0, so we don't need to round up. So it'd just be about 20 inches. So the size of the TV, the way that this TV would be advertised, is a 20-inch TV. Okay, so just to kind of recap really quick, Pythagorean theorem is the theorem that you can use to find unknown sides of right triangles. It specifically only works for right triangles, so it's a triangle that has a right angle in it. And it works when you have 2 out of 3 sides. So notice like here we had 2 legs, we were missing the hypotenuse. Here we had a hypotenuse and a leg, but we're missing one leg, so we still had 2 out of the 3 sides. And then here we had 2 legs, but we're missing the hypotenuse. So again, we had 2 sides out of the 3 total. And so that's kind of the criteria that you need for this theorem to work, is you need a right triangle and then you need 2 out of 3 sides.